Wow, that was a very exciting start. Thank you for the kind introduction. Hey, I'm Liz. Super excited to be here. A little bit about myself first. I'm a developer advocate at Sentry. I have the pleasure of working with an amazing team of people who are building a tool to report errors across a bunch of different SDKs. We're an open source product. Obviously won't have time to talk about all of these today. I don't know very much about all of these yet because I come from the strange land known as web development. So I'm just going to be talking about JavaScript. Since this is a JavaScript audience, I'm sure you can relate to me when I say that JavaScript sometimes makes me want to throw things, sometimes literally. I got curious about how this works. Like, once we generate errors in our code, how do we then put it somewhere where it becomes useful to us? For example, all of our modern-day error reporting tools that really make our lives easier, instead of taking it for granted, I wanted to figure out some of the history leading up to this, and how did we get to where we are today? Specifically, how did JavaScript evolve to the point where we can make use of its features to do this? Because it didn't used to be possible. Now, in order to learn some of this, I got to indulge in my favorite hobby, which is reading old books, specifically old technical manuals. It's the best section of the library. I highly recommend taking a look at that. Now, I'm going to start with a few quotes from some of my favorite old books that I found in learning about this. So the first one here, Laura Lemmy's Web Workshop from 1996. Does anyone here, quick show of hands actually, anyone remember Netscape Navigator 2? Did anyone use that? You were programming JavaScript in 96. Yes, I want to talk to you afterwards. So in those days, the way we programmed JavaScript was by using alert dialogues. And it's not really the best way to do JavaScript, is it? In Laura's book, she outlines two techniques for debugging JavaScript at that time. The first is to use those alerts, window.alert, and she says basically just sprinkle it through your code. So every time you do something in your program, change variable, alert, run a function, alert, and then once you figure out how to solve all your bugs, you go back and delete all the alerts. There's a slightly better way that she recommended, which is to use window.open and then write to that window all the debugging information. So then you have something that looks more like this. Not that much better than alert, but people are very creative with finding solutions to this early on. Now, in 1997, which I was surprised that this happened so early, we had a JavaScript debugger in Netscape. This is the official manual. And you can see that they actually had breakpoints and a bunch of other cool features. If we skip ahead just a little bit, I mostly just wanted an excuse to show the cover of this book, because this guy is amazing. I really feel like he's looking deep into my soul when I look at this. Now, his book outlines some ways that the debugger evolved over time. This was published in 2000, and you can see some of the ways it got better, definitely a little bit closer to what we have today. You could actually see the call stack. You had breakpoints in a visual way, so you could actually click on the line numbers the way we do today, and then see a list of your breakpoints on the side. Fun fact, it's a total tangent, but I couldn't help myself. How many of you are familiar with the origin of the term breakpoints? Anybody? I think maybe I saw one hand. I see one. OK, one hand. So if we go back to the 1940s and 50s, which I've heard a lot about thanks to my dad. He actually used to work at IBM in the early days of mainframe computers. A little bit before that, the ENIAC computer was programmed. You can see all the cables. And one of the first programmers who worked on it was this woman standing in the front, Betty Holberton. She was one of the 6 first programmers of that computer. And she's credited with inventing breakpoints, or I guess at least coining the term breakpoints. And she says in an article, an interview with her, that the reason we call it that, the reason she started calling it that, was because we pull those wires out to stop our program and then see what's happened. And that's how debugging worked in the 40s. And in doing so, you literally broke the point of contact. And then there you go, a breakpoint. So fast forward again to 1997, where we left off with our JavaScript history. I found another interesting article this time, posted in 1997 by Microsoft. I found very interesting. They recommended, to avoid having users see the default error dialog, they say you should use window.onError to trap the alerts and display your own message instead of the error. So that way your users won't really get to see under the hood of your application. So this is the code that they recommended. You copy-paste. Alert, error handled. Return true to avoid default behavior, and then set that to window.onError. So we had that error handler at least as far back as 1997, almost as old as JavaScript itself. This is what it looked like. So imagine you're using an application in the early days of the web. You click a button, maybe you're submitting a form, and then you see this, and then this, and then this, and then this. And you're like, oh, great. This developer really knows what they're doing because I don't see any error messages. I just know that everything's under control. Great. Apparently, that was how you did it. What's scary to me, though, is if you fast forward all the way to 2011, as you can see in this O'Reilly book, I'm going to show another quote from this one, which is one of my favorites. So they recommend another usage for window.onError, but they say that the onError handler is just a holdover from the early days of JavaScript, back when we didn't have try-catch. And, quote, it is rarely used in modern code. That made me very sad. But maybe just because I work at Sentry and I'm looking at JavaScript stuff, I feel like the window.onError is used all the time. It's actually the backbone of our reporting tool and all the other ones that work on front-end JavaScript. So why in the world did this book say it wasn't used? Why weren't people using it? Because I'm thinking, this seems like one of the most useful global error handling, event handling functions. The reason is because they only had 3 parameters available back then. So you had your message, URL, the file, and the line number. And so you get these alert dialog boxes. You see the URL, the line number, and the message. The important thing that's missing here, though, you'll notice, is where's the stack trace? I take this for granted. Anytime I'm working on a website, I always have the console open in my browser, and I get to see this stuff. With every single error, I just see exactly what happened and when, and the entire call stack, and I can actually click through and see everything. But you couldn't do that in the late 90s. Now, it wasn't until 1999, 3 years later, after people were using JavaScript with all these crazy workarounds, this was when they finally introduced try-catch into the ECMAScript standard. So you got your try-catch. Imagine we're running a function, let's say, called break-everything. And in an ideal world, when something like this goes wrong, we want to be able to send this to some sort of centralized error reporting tool so we can actually see what's going on. And we want to capture that error object, which includes the stack trace, and then send that whole thing, right, instead of, say, just the line number. Problem is, since at the time you couldn't get that error object from the window.onError handler, you had to use try-catch for everything. And there's a lot of different places you could have errors. It doesn't make sense to just try-catch once for your entire program, especially since JavaScript is asynchronous. There's a lot of different places you need to worry about this. Never mind that try-catch wouldn't work with asynchronous code back then. So you had to basically just try-catch all the things, and your code didn't look so great. It's a lot of extra typing. So the other big problem, even if you did try-catch all your stuff, was how, in the late 90s, would you actually send the error to somewhere? Right? How do you send requests behind the scenes so the user doesn't have to worry about it, doesn't have to refresh the page every time they do something that might cause an error, which is literally every interaction with the web page? Back then, of course, we used forms, right? You want to send information, you have to go refresh the entire page. It's not really the best way to handle errors. Now, I thought it was really interesting. When I first read about debugging in the 1940s, I thought, wow, they had it really, really rough. Like I can't imagine debugging my program by walking around a room with my physical body, like moving through space and like pulling wires and looking at things. I mean, I guess I would get more exercise than I do these days, but it seemed pretty difficult. But on the other hand, they also had it easier than we do. because all of their code ran on one machine. They didn't have to worry about potentially millions of different clients running their code on other machines that you have no control over, that you can't see inside. So we have all these black boxes to worry about. Now, as far as sending information to all of those different machines, from all those different machines to a central place where we can see at least some of what's going on in them, we needed another technology that was being formed as early as 1996, but took quite a few years, roughly 10 years, to really catch on. And you can see some evidence of when that became mainstream from articles like this in 2005 from the Wall Street Journal, talking about things like Ajax, the programming technologies that's the buzz of Silicon Valley. Oh my God, Ajax, what's this new invention? But of course, Ajax wasn't anything new, and it was just a convenient acronym. It was actually coined by Jesse James Garrett in 2005 when he was outlining what people were already doing at the time. One example you may or may not remember is Google Suggest back in 2004. People wrote all these blog posts saying, oh my God, this is the most amazing thing I've ever seen. You can type into this box, and this stuff appears in real time, showing you how many people searched for each of these related terms. And autocomplete was amazing. That was thanks to Ajax. Now, it actually wasn't standardized by the W3C until 2006. So you'll see a general trend on the web. Anytime we have to deal with standards across lots of different people involved in developing these things and experimenting, it takes a few years for the standards to catch up. Now, another tricky one that made error reporting a little bit more difficult, and something you definitely have to keep in mind, is the same origin policy. I'm sure you're all familiar with this and have to deal with it every day. I know when I was starting out in web development, this was a big headache, because I also didn't totally understand it. But as a quick recap, imagine that you're pulling a third-party script, say from a CDN, which is very common today, and you're using window.onError to get information about errors that went wrong in your application. But you're going to see messages like this. No stack trace, no line number, nothing helpful at all. Now, the same origin policy is as old as Netscape Navigator 2.0 and JavaScript itself. It's a fundamental tenet of the internet. It just says that a web browser can permit scripts from two websites to communicate only if they have the same origin, like the same domain, for example. There's some great slides, these are kind of old, from I think Stanford's web security team. Basically just showing if you have two windows open without the same origin policy, you would be able to just go from one, like, quote-unquote, evilwebsite.com to somebody's bank website, if that was also open, and just literally do, like, .inner.html, grab their bank account information. So it's good that we can't do that. On the other hand, there's even more danger that's less obvious that I found pretty interesting. This is also from 13 years ago, about letting error handlers give clues about what users are doing that are unintended. So even if you can't run scripts on somebody else's domain, even just being able to see their error messages can be a security vulnerability. So this example that he's pointing to here looks like this. If you include a website, for example, Gmail, you'll get an error message by trying to do this. But the interesting thing is, if you're logged in, you'll see some error on line 8. This was his example. And if you're not logged in, you'll see the error on line 3. And people could exploit that to find out which services a user was logged into at the time and use that to make a more targeted attack on them. So it's tricky. Security is very tricky. How do we protect users while also having the flexibility to be able to understand what's going on in our code? The solution for now, it's also a bit messy, but cross-origin resource sharing, you may also know it as CORS. Here's a standard first solidified in 2014 here, and it's just a mechanism to allow us to say which domains can share information, which other domains. And there's only 2 steps you have to do to get your third-party scripts to work with this so that you can actually see your error messages in full detail. First step is set this lovely header, it's best name ever, access control allow origin. Rolls off the tongue. In this example, it's just set to an asterisk, meaning any domain. And then on your client-side code, in your script tags, you just have to include this attribute cross-origin. The default value is anonymous. And there you go. It'll transform this not-so-useful script error message into your full stack trace. Yay. OK, so now we're able to get that error object, say using try-catch for now. We're able to use Ajax to send it to the reporting tool in the background so it doesn't affect the user's experience too much. And we're able to then do something cool on the other side with our reporting tool if we want to. But the problem is, again, window.onError only gives you a few things like just the line number. Of course, at some point, we started writing a lot more JavaScript code than we used to and using it in ways it wasn't intended to be used. So if you were to use this in your error reporting tool back then, you would see error on line 1 for literally everything. This is line 1. Your entire application is line 1 because your code is minified. Not so useful. You can use source maps to get around this, of course, and that's a topic for another day. There's a lot to say about that. But the interesting thing to me was how this on-error handler evolved over time. We can look back. This is a commit from 2012. You can see all this history backlogs in the whatwig GitHub. This is the HTML where they're documenting everything that you can use with the DOM. And somebody suggested the brilliant idea of adding a column argument. So at least that way, you can see the line number, which is your whole program, but at least with the column number, you can identify where exactly something went wrong. Now, even more importantly than that, there's, of course, the idea of getting the stack trace. So up until now, there was still no way to get that stack trace using window.onError. So what I found interesting about this is this issue was open 13 years ago, and it was closed 6 years ago. It took a little while. But finally, here in 2013, you can see they added that argument, the error object itself, to the on-error handler, which it's funny that it took so many years for on-error to give you the error. I don't know. Now we got those last two parameters. So not just the message URL and line number, but also the column number and that wonderful error object. So if you take a look at can I use right now, you can see getting that stack trace, the stack property on the error object, is really well supported. So we're good. Problem solved, right? Then there's this little note at the bottom. This feature is non-standard and should not be used without careful consideration. Oh, why is that? I actually didn't know that. I thought it was standard because I see it everywhere. Well, if we were to try this, what would we get back? You actually shout it out. Yeah. So it actually just gives you a string. I thought it was going to be an object, or at the very least an array, right? Because a stack trace is like a list of things, but no, it's just a giant blob of characters. I could not figure out why. I've done a lot of digging in here. I still don't know why it's just a string. Because back to 1997, when we had the debugger running in Netscape Navigator, there's our call stack. It's right that clearly we could get that information. The browser has it somewhere. And if you're using Node, you can get access to that. It's a lot easier, but on the front end, blah. But you know how it goes with front-end JavaScript reporting. Now, because it's a string, it's readable, obviously, with formatting, but this is what it looks like in Chrome. And then this is what it looks like in Firefox. A little bit different. And then this is what it looks like in Safari. You'll notice it has this global keyword at the end that neither of the others have. So I guess the solution is, well, we just have to parse all of everything from each browser differently. And this is where we are today in 2019. That, unfortunately, is the answer, everybody. Thank you. OK, bye. Regular expressions. Yay. This is how we do it. This is still how we do it. Luckily, of course, there's libraries that handle this for you. So we've got TraceKit, which is actually a really nice open source one. This is the one that we use at Sentry. We just pulled that into our repo, and one person in our team single-handedly rewrote it to get it to do only the parts that we needed. But it's a really good tool. It's been around a while. Another one that has more features on top of it and is still being used and updated today is StackTrace.js. So definitely recommend checking out both of those. Obviously, you could roll your own parsing. I mean, you can write regular expressions, so you're good to go. But it's obviously nice to not reinvent the wheel. And another layer on top of that, of course, are then all of these error reporting tools that we have. So this is just one example of how you would do this with Sentry. It instruments your code in a very nice way, and then also has, in addition to parsing those stack traces and a bunch of other things, like giving you a nice UI, all of the error reporting tools out there today basically do the same thing, and they all work like this. You import the library. You initialize it in some way. In our case, you give a unique identifier, the data source name. And then anywhere in your code, if you're throwing an error, behind the scenes, it's already capturing that and sending it to Sentry. So you can, or if you're running it locally, since it's open source, you can handle that yourself and just get it. And then you get this nice UI. So there's a lot of tools that do this today. It's pretty nice, but a lot had to happen before we could even get here, unfortunately. And I don't really see this changing too much too soon. I think we really need that .stack property to be standardized, so hopefully that's on the way. I don't know how long it'll take, maybe another few years. But that's where we are. So JavaScript errors, I mean, they're not so great, but we found ways to work around them. And hopefully, in the future, we'll have even better tools. We've had a pretty good track record so far of people coming up with creative solutions to all of our limitations in JavaScript, even though we have a lot more tools available to us with other server-side tools. But front-end's starting to catch up. It's definitely something, I mean, as you all know, the reason we're all here definitely can't be ignored. There's a lot of innovation happening in this space. So I just wanted to say a really quick thank you to some of my teammates who worked on our JavaScript SDK, helped me understand it, giving me some feedback on my research, and just being really cool people to work with. So if you're interested in learning more about some of these tools, here's a few links to get you started. And thank you very much. I'm more than happy to speak with any of you later. You can find me on the internet at Learning Nerd on Twitter, GitHub, and thank you so much.